Okay, guys, so we are on section 10.3 combinations. We just talked about permutations, and if you'll remember, on permutations, order does matter. In combinations, order doesn't matter. Okay, so let's start off with that definition. It says a selection of objects without regard to order is called a combination. Okay, so we're going to start off with just an example. Example 1 says if you are choosing two business classes, yes, let me spell that right. I apologize. From three choices, list all the permutations and combinations. Okay, so we're going to start off with our permutations like we've been talking about. And those permutations, it doesn't ask me to find how many, it does just ask me to list them. Okay, so let's label them. A will be maybe business class 1. B is business 2. And C would be, of course, business 3. Okay, so in a permutation, of course, the order does matter. So if we're picking two business classes from three choices, I could pick A, B, I could pick A, C, I could pick B, A, B, C, or C, A, and C, B. So we see permutations, I do have 6 there. Okay, if I'm talking about combinations, where order does not matter, well, I have AB, I have AC, but when I go to list BA, guys, we've already listed BA. Order doesn't matter. If I pick business 1 and then business 2, that's the same thing as picking business 2 and business 1. So I can't list BA. BA has already been listed. That's AB. I can list BC. We haven't listed BC yet. Okay. Now let's go over to the C's. If I start with business 3, C, if I say CA, well, I already have a C listed. So can't list CA. Okay, what about CB? If I try CB, you'll notice I already have BC. So we can't list that either. So as far as combinations go, I only have 3. Okay, example 2. Now you've got to be able to pick out who's a permutation and who's a combination. Decide if each selection is a permutation or combination. Okay, A says a 5-digit passcode is chosen from the numbers 0 through 9. Guys, we talked about choosing passcodes all in the last section. And remember, if I'm choosing a 5-digit passcode, think about it, guys. If I list 5, 4, 3, 2, 1, that's different than 4, 5, 3, 2, 1. Okay? That's a completely different passcode. So, a 5-digit passcode, then, order does matter, which means this is a permutation. Okay, let's look at B. B says a gardener picks 4 vegetable plants for a garden from 10 choices. Okay, so guys, maybe this gardener's gone to buy seeds, maybe at like Home Depot. Okay, so he's buying seeds and he's got 10 choices. Guys, if he buys, let's say, carrots, what else do we have? Okra, corn, and squash. Okay, so there's 4 vegetables. He picks those off the shelf. He's going to purchase those. That's the same thing if he buys okra. If he picks okra first, carrots, corn, and squash, then it's the same thing, guys. These are the same. So that means order does not matter. Therefore, it is a combination. Okay. All right. Let's look at the combination rule. Okay. I have NCR. This time we use a C. That capital letter is a C instead of a P because it's standing for combination instead of permutation. And the rule for a combination is actually includes the rule for a permutation, and it is NPR factorial over R factorial. If we write that out completely, that's really n factorial over n minus r factorial. So you see that permutation right there, rule for permutation, all times r factorial. This right here is actually my permutation. Okay? So let's look at example 3, and we are going to actually work it out mathematically in example 3 first, and then I'll show you how to do it on your calculator. So we have find the number of combinations of 10 objects taken 5 at a time. Now remember, When we're working these problems, we need an N, we need an R, and we need to know if it's a combination or permutation. Well, they've told me it's a combination, so I'm good on that. What's my N going to be? Remember, that's the total number of objects. So there are 10 objects, and R is the amount we're taking or the amount we're choosing. And we'll talk about where that word choosing comes into play in a minute. So taking 5 at a time. So R is 5. So I have 10, choose 5. And we'll talk about how I'm saying that in just a second also. So that's going to give me 10 factorial over 10 minus 5 factorial, all times 5 factorial. Okay, well, the 10 factorial, that's going to give me 10 factorial over 5 factorial times 5 factorial. Well, one of those 5 factorials, of course, is 5, 4, 3, 2, 1. That's going to cancel out the 5, 4, 3, 2, 1 in the 10 factorial. So on the top, I have 10 times 9 times 8, 7, 6, all over. And I've used one of the 5 factorials. I have one left, so I have 5, 4, 3, 2, 1. Guys, I'm just going to show you how I kind of do this in my head. I know that 5 goes into 10 2 times, so that 10 turns into a 2. 4 goes into 8 2 times, so that 8 turns into a 2. 3 goes into 6 2 times, okay, and then actually this 2 will go into 2. And of course, 1, he's just 1. So this turns into 2 times 9 times 2 times 7. That's going to give me 36 times 7, which actually is going to equal 252. So the number of combinations of 10 objects taken 5 at a time is 252. Okay, you'll notice when I wrote this, my NCR, I said, it is read as N choose R. Okay, it's read as N choose R, and sometimes, depending on your textbook, especially if you take statistics, they will write it N choose R. They use a big parenthesis set, and the N goes in the top and the R goes in the bottom. Sometimes on your calculators, it is also denoted that way if you're using a different calculator. Okay, let's look at example 4. I think I can squeeze it in right here because it's going to wind up being a calculator problem. An instructor posts a list of 8 group projects to the class website. Every group is required to do 4 projects at some point during the semester. How many different ways can a group choose the 4 projects they want to do. Okay, so an instructor posts a list of 8 group projects to the class website. Every group is required to do 4 projects at some point during the semester. How many different ways can a group choose the 4 projects they want to do? Okay, so as usual, we need an N, we need an R, and we need to know if it's a combination or permutation. Okay, guys, this doesn't state that order matters. If they pick 1, 2, 3, 4, that's going to be the same thing as 2, 1, 3, 4. Okay, so this is going to be a combination. Okay, how many objects are there? What is N? Well, that's your amount of group projects. There are 8 group projects, and they are to choose 4. So we have 8, choose 4. Okay, so we're going to go over here to our calculator, and I'm going to clear that out for you guys. Oh, wrong button. I'm going to clear that out. And we are going to say 8. Then we go back to our PRB. We're going to pick 2 this time. You notice it says NCR. So 8, choose 4. We hit enter and we get 70. Okay, there's 70 different ways those 4 group projects can be chosen out of the 8 listed. All right, let's look at example 5. Example 5 says, on an exam, a student has to pick 2 essay questions from 6 essay questions and 10 multiple choice questions from 20 multiple choice questions to answer. How many different ways can the student pick questions to answer? Okay, so let's talk about this. Actually has 2 problems involved in it that we have to do before we can find the total. So it says a student has to pick 2 essay questions from the 6 essay questions. So that's going to be my first N, my first R. And if I can just pick any 2 questions from those 6, the order is not mattering. If I pick question 1 and question 2 to answer, that is the same as picking question 2 and question 1. Okay, so it is a combination. There are 6 to choose from, and I am picking 2. So N is 6, R is 2. In my other situation, so that's going to be, let's just write that, that's going to be 6, choose 2. Okay? In my other situation, I have 20 multiple choice questions, and I am to pick 10 to answer. Okay? This is still a combination, guys. If I pick all the even ones, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, That's the same thing as picking question 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. Okay, it's the same. The order doesn't matter. So once again, it is a combination. And this time I have 20, choose 10. And I'm just going to use that particular problem. I'm going to recopy it because I can just go over and change those numbers. And I've got 6, choose 2. And that does give me 15. I'm actually going to go ahead and redo that one. 20, choose 10. That one's a little bigger. That's going to be 184,756. We're going to multiply those together. Okay, guys, so I had a slight recording issue on example 5, but I'm going to pick up from there. Pretty much what happened was I began recording after a pause and the microphone didn't pick back up. So you've got example 5 and example 6 without any voice overlay on there. So I decided just to re-record it. So we were on example 5. On an exam, a student has to pick 2 essay questions from 6 essay questions and 10 multiple choice questions from 20 multiple choice questions to answer. It says how many different ways can the student pick questions to answer. So what we had here was we had gotten to the 6, choose 2. We knew that was 15. We had gotten to the 20, choose 10. We knew that was 184,756. Now, in order to get the total different ways that the student could pick questions, we needed to multiply those two together. So we said 15 times 184,756. That did give me 2,771,340. Okay, so example 6, since unfortunately it didn't record, I'm going to read through the problem. And it says a 4-person crew for the International Space Station is to be chosen from a candidate pool of 10 Americans and 12 Russians. How many different crews are possible if there must be at least 2 Russians? So what makes this one different from the others is that we have that at least going on there. So we have to have at least 2 Russians on that 4-member team. Well, that means we could have 2 Russians and 2 Americans. We could have the scenario of 3 Russians and 1 American, or we could have all 4 Russians and 0 Americans. So this is a combination. Both sets are combinations like they were in example 5. Okay, so the first scenario that we find is the 2 Russians and 2 Americans. So there are 12 total Russians. N is 12. We are choosing 2, so 12 choose 2 times 10 choose 2. And I will flip over here to the calculator and show you that. We had, I can go back up. We had N choose 2, and you can go ahead and put that all together and take that and 10 choose 2, and you can multiply those. Make sure you put them in the parentheses so that they'll multiply correctly, and that does give you 2,970. Okay, when we go back over to the 3 Russians and the 1 American, that's going to be 12 choose 3 times 10 choose 1. We're going to put that in the calculator also. Okay, we did have that up here earlier, and that does give me 2,200. Once again, you can multiply those. And then our last scenario is 12 choose 4. All 4 are going to be Russians and no Americans, and that does give me an answer of 495. Okay, now to look at all the possible ways we could do that, we need to combine all those situations. So we're going to say the 2,970 different ways for 2 Russians and 2 Americans, plus the 2,200 different ways of 3 Russians and 1 American, or the plus the 495 4 Russians, and 0 Americans, which gives me a possibility of 5,665. And hopefully that all will come through on the recording.